Okay, so in this video we want to show that all numbers of the form a plus square root of q is algebraic for a and q in the rational numbers. So we will prove it in the same way as we did it for a specific example of 1 plus root 2. So the way is that we will just square this, a plus square root of q squared, and then we get a squared plus q plus, and then we do the cross term a and then square root of q. Now we did a similar thing to what we did before. So we notice we want to get one of these somehow to cancel out this q over here. So that makes sense. So what we're going to do is we're going to multiply this side by 2a, this part by 2a, and subtract it off this side and add it on. So basically, or in fact, we don't need to do that. We just need to subtract and add on 2a squared. So let's just go with me for a second. We're going to subtract and then add on to 2a squared. And you'll see why in a minute. So minus 2a squared plus 2a squared plus 2a square root of q. Might be going a bit off, so square root of q, okay? And then what we can see now, okay, just leave this part, where we can actually simplify it, we can get, this is q minus a squared over here. And then over here we get plus 2a plus square root of q. And now if this is alpha, if this is alpha, we have that alpha satisfies alpha squared minus 2a alpha minus q minus a, this is no alpha, a squared equals 0. And so so basically this at this point we can stop, because all we need to do is replace alpha by x, and then we get a polynomial for which alpha is the root. So we're done. We just showed that all numbers of this form are algebraic. So that means that, for example, 3 plus root 3, or 7 plus root 5, even if you can't immediately tell what the you can, you just need to plug these numbers into the thing, but these are all of these are algebraic. So in the next one we will show something even better. First of all, that if you add a rational number q to any algebraic number, then the result will be algebraic. Okay. We will also show that if you multiply a rational number to any algebraic number, the result will be algebraic. So if you want, you can give this a go yourself. And so once we have that, we get that for any two algebraic, any two rational numbers, let's say a and b, maybe b is not good, let's do any two rational numbers x and y, then a x plus alpha y is in q bar, which just follows from these two. So if we have these two, we can get this, just from these two. And then one more thing we want to show is that if you have a rational power that's non-zero, so q is not equal to 0, and A and alpha is rational, then alpha to the Q is in the rational numbers. Sorry, not in the rational numbers, in the algebraic numbers. For all Q, that's for all rational Q, that's non-zero. So every time I use a Q anywhere, it'll be algebraic. Every time I use an alpha, it'll be every time I use a Q, it'll be rational. So Q is always rational, and A alpha will always be algebraic. Okay. Hopefully I don't mess that up. Okay, so we'll carry on the next video. We'll prove these results. Okay, see ya.